So you might have come across what is CPU scheduling and what are its criteria and what are the types of CPU scheduling. So hi, this is Akash and I am here to make things simple for you. So let's get started. So what is CPU scheduling? We need to understand that at the very beginning. It is a mechanism by which OS tries to maximize CPU utilization with the involvement of multi-programming. Okay. So a lot of programs have to be executed by the CPU at the same time. I mean virtually at the same time. Okay. So how can CPU achieve that? So that is achieved using the CPU scheduling. Like CPU just switches over from one process to another process in such a short time that we don't even realize that it is not executing the processes concurrently. Rather, it is just switching among the processes here and there. We don't realize that. Okay. So that is achieved using CPU scheduling. And what is the scheduling criteria? The algorithms are designed based on the following criteria. So the first is CPU utilization. I mean CPU should be utilized to the maximum. To keep the CPU as busy as possible, that is one of the main criteria of all the CPU scheduling algorithms. These scheduling algorithms are aimed at achieving multi-programming through the CPU. And based on these algorithms, CPU scheduling or switching over of CPU from one process to another takes place. So the CPU scheduling algorithms are very important. So next we have throughput, next criteria. Throughput means number of processes completed per unit time. So these are the number of processes which are completed by the CPU per unit time. Then comes turnaround time. It is the time from a process is submitted to the time for completion of the process. So suppose the process is submitted after 2 seconds and it is completed after 6 seconds. So what is the turnaround time? It is 4 seconds. Okay. So turnaround time is the time of completion of job minus time of submission of job. Next we have waiting time. Okay. So it is the sum of time periods spent waiting in the ready queue. As we have seen in the previous video that before the execution or before the CPU's control gets transferred over a process, the processes are waiting in the ready queue inside RAM. So the sum of time periods spent waiting in the ready queue, that is known as the waiting time of a process. That how much the process has waited for its execution. I mean to start its execution. Okay. So the processes wait in the ready queue and the time spent there is known as the waiting time. Next comes the response time. So it is the amount of time the process takes to start responding. Okay. So the first response whenever we get, that is the response time. Remember the diagram we have discussed in the previous videos. That is the diagram. What actually happens? CPU's control gets transferred over the process for its execution. And what is the program that is responsible for transferring CPU's control over the process? That is known as dispatcher. So what is dispatcher? If somebody asks you, what do you answer? So it is a module or a program which is used to transfer the control of processor to a process that is selected by the short-term scheduler. So the short-term scheduler selects the processes from the ready queue for that are ready for execution, that transfers the control. So the dispatcher transfers the control of CPU to that process that has been selected from the ready queue for its execution by the short-term scheduler. So the short-term scheduler selects the process from the ready queue for execution while the dispatcher controls, the dispatcher transfers the control of the CPU over that process. So the time taken by dispatcher to load the program counter and to start running the program is called as dispatch latency. I mean when the dispatcher just transfers the control of CPU, it loads the program counter with the state of the process. Okay. So the time taken by dispatcher to load the program counter and to start running the program is called as dispatch latency. So basically we have two types of scheduling, non-preemptive scheduling and preemptive scheduling. So what is non-preemptive scheduling? When process under execution completes its burst time without interruption. By burst time I mean the execution time. Okay, so when process under execution completes its burst time without interruption. So it is a kind of scheduling algorithm in which if the process P1 is executing and it is having a burst time of 5 milliseconds, then if a process P2 comes for execution, it cannot interrupt P1. P1 gets executed for its full time of 5 milliseconds, and after that only P2 will start getting its execution. So that is a non-preemptive scheduling in which the process under execution completes its burst time without interruption. Next we have the preemptive scheduling. So what happens in the preemptive scheduling? Suppose there is a process P2 which is having a burst time of 4 milliseconds. Okay, and there is our process P1 which is having a time of 5 milliseconds. So P1 is suppose getting executed right now and P2 comes. So P2 comes, so it can actually preempt that process or interrupt that process and starts its own execution. That is known as preemptive scheduling. So we have the actual type of scheduling algorithms which are FCFS, first come first serve. That is whichever process comes first starts its execution first. That is a non-preemptive scheduling, that is the process cannot be interrupted. Next we have SJF, which is shortest job first. Okay, so it is a kind of scheduling algorithm in which the process having the minimum burst time gets executed first, followed by the second process, and the process under execution cannot be interrupted. That is why it is also non-preemptive. Okay, then we would see what are the preemptive scheduling types, the preemptive scheduling algorithms. So this is SRTF, shortest remaining time first. So whichever process is having the shortest remaining time for completing its execution interrupts the other process which is having the longer remaining time. Okay, we will all discuss these algorithms in the coming videos in detail along with the example. Then another is the priority scheduling, which is also a preemptive type of scheduling. Okay, so suppose P1 is having the priority 1, the highest priority, and P2 is having the priority 2. So if P2 is executing, then P1 can interrupt the process because P1 is having higher priority. Okay, then comes the round robin algorithm, which is also a preemptive algorithm. So ready queue is assumed to be circular and it depends on time quantum. A certain time quantum is assigned for execution, like on a case of time quantum of 2 milliseconds, if P1 is having a burst time of 3 milliseconds, while P2 is having a burst time of 4 milliseconds, then suppose P1 starts its execution first in the circular queue inside the RAM. Okay, so it is executed only for 2 milliseconds because in the round robin the time quantum is defined as 2 milliseconds. So a process at one time, at one go, cannot be executed for more time than the time quantum defined. So P1 executes for 2 milliseconds, then control gets transferred, that is context switching happens, and P2 gets executed for 2 milliseconds. Again the control goes back to P1 and completes its execution, and then finally the control returns back to P2 for completing its execution. So this is round robin and it is executed using circular queue inside the RAM. The processes are stored in that circular queue. Okay, so I hope you like the video. We will discuss all the algorithms in detail in the coming videos one by one along with the example. I hope you got a basic grasp of all these concepts which you would be able to apply in your exams, and in order to get more content, please do join our Telegram channel and Facebook group, link for which is given right there below, and do visit our website teachmycourse.com. Okay, and I wish you happy learning.